Okay, everybody, just a quick little review video here of looking at the electrochemical cell or the voltaic cell versus the electrolytic cell, just to kind of like tie the two together and compare and contrast a little bit. So again, a short video here, just real quick. If you look at the two side by side, and this should be page 15 in your notes, I believe, close to page 15. Number one, we split that in half. So we look at the two different cells. We'll see the voltaic cell to the lower left here, and we'll see the battery here. Again, you don't have these diagrams on your sheet, but again, we just remind you what they look like when we see them. Okay, and again, this is the spontaneous one at the bottom. So if we take a look really quickly, okay, and in the voltaic cell, so this column here will be the voltaic cell. We have our anode is where oxidation takes place, always at the anode. Okay, cathode is going to be taking place always reduction. So reduction at the cathode, we know that already. Okay, and just to remember that the anode is the source of electrons in the in this voltaic cell. So the electron flow will always be from the anode to the cathode through the wire end of it. Okay, through that light bulb, through the wire. Okay, in the electrolytic cell, however, anode still takes place. The oxidation still takes place at the anode, and reduction still takes place at the cathode. However, the signs are going to switch here because because it's forced. Again, remember, this is a forced in reverse of this. So we reverse the charges and we take those electrons and force them back. So because this is using a power source, we would have those signs mixed. Okay, electrons are going to flow from anode to cathode in the voltaic cell. Okay, also in the voltaic cell, we have two cells. Again, you have two half cells. You think of half cells. Okay. All right, where you only have one cell in the electrolytic, which is the main cell where everything's taking place. Okay, you do have a salt bridge where you have ion flow to keep those cells neutral. I mean, you want to keep cells neutral. Okay, you need neutral cells for the electrons to pass. Okay, and you have no salt bridge in the electrolytic cell because you have this electron pump that's pushing the electrons through. Okay, you have a spontaneous flow of electrons. This is a natural flow of electrons, okay, from the top of table J to the bottom. Okay, again, the higher element on table J is the oxidation. The lower one, lower ion, is the reduction in that case, okay, the reduction of the ion. Okay, and this is non-spontaneous. Again, this is forced redox. Okay, important to know that. Okay, in the voltaic cell, you can have chemical energy, produces electrons, produces electricity, where in the other one, you have your power source. This is your power source. Okay, is needed to produce a chemical reaction or chemical energy. All right, the voltaic cells is a power source. It itself produces electrical power. Okay, and this requires or needs a power source in order to operate. So it needs electricity from the outside. It needs an external power source. You can think of this as becoming external, okay, a power source to produce the electricity. So that's really a quick little overview of this. Again, really fast. If we take a look at the cell, we're using a zinc and a copper, okay? And again, zinc is above copper in the table, copper 2+. So zinc will be oxidized at the anode. Electrons will flow out of the anode through the light bulb, okay, and enter into the cathode. Okay, your copper ions here in the solution will jump onto the cathode and be reduced. Okay, and you can see down here, you see the reduction of copper 2+, plus 2 electrons is copper 0. That will cause this to this will gain mass here. All right, and on this side you will have zinc becoming zinc ions, okay, and you will have the oxidation of zinc. So zinc will become 2+. Here's the electrons that goes back to the other side. Okay, again, we're not going to worry about the voltage here, so don't worry about that for now. Okay, so your anode is on this side, your cathode on that side, electrons flowing from anode to cathode. Now, if we were starting to build up in some positive, negative ions flow to the negative cell, positive ions flow to the positive cell. So that's a quick overview, okay, of the voltaic cell. Again, the higher element on table J is going to be the anode. All right, important to know, and the bottom one would be the cathode. Okay, in the electrolytic, we're going to have a battery here. Again, this would be the negative side of the battery. This would be the positive side of the battery. Okay, electrons will flow this way and be pulled back that way. So here's your push, here's your pull. Okay, so electrons will flow in this direction, become negative. Okay, electrons will be on the spoon. Silver ions will go and be reduced on silver, so you will form silver here. So this becomes your cathode where reduction takes place. All right, and this will be the negative side. Okay, and the anode is on the other side, which would be positive. Okay, this is where oxidation is taking place. So silver 0 becomes Ag plus into the solution. So you have Ag plus being formed at the same time Ag plus is getting on the spoon. All right, so that's a quick overview of what's going on with the two cells. I would go over it again, make sure you practice a little bit. I would definitely go over the multiple choice and practice problems, and then come to class, come to support, let us know if you have any problems. Okay, have a great day. Take care.